Hello, welcome to video number 66. We're going to talk about some special rectangle problems today. I'm Mr. Miller.
And I'm Ms. Les. Hi.
Hello there. All right, we're going to start with Nick Jonas. I don't know if you're a Nick Jonas fan or not, but we got this beautiful picture of Nick Jonas here, and it has a border around it. It says that the original picture was 12 by 16. So maybe Ms. Les, you can label that.
Put the measurement there.
Yeah, that's kind of like the blue part, 12 by 16. And then we put a 2-inch border around it. And they want to know the total area of the picture and the border.
So 2-inch border means 2 inches on the right, 2 inches on the left, going this way. Let's put it in. And also 2 inches going up and 2 inches going down.
So we're going to tell you what not to do. This is an old trap. When people do this, they add 2 inches to the width and 2 inches to the length. They would say 14 by 18 and multiply it, and unfortunately be absolutely wrong.
Incorrect. So we don't want to do that. By the way, so what is it? What would they get if they did that?
Okay.
So we got the area.
It would be 252, and that's absolutely wrong.
252 inches.
So maybe we'll
so you cannot
cross that out.
Do that.
And the 252. So they think because we added 2-inch border, it adds 2 inches to the width and length. But if you look carefully, we added 2 inches on both sides, the left and right, and the top and the bottom. Mm-hmm. So we really added 4 inches to the width and 4 inches to the length.
Yes. So we have 16 inches times
20. There it is. Mm-hmm. All right, so 16 times 20, that should be 320, but I'm going to make sure today. It is 320 inches square. So this problem, there is a problem like this on the upcoming quiz. You want this kind of problem, but you got to remember to add the border on both sides.
Yeah, be very
all
careful.
4 sides.
It's 2 both ways. So I'm adding 2 and 2 and also 2 and 2 on both sides.
Okay, let's take a look at it again. The bowls picture here. The original picture is 28 inches by 35.
So 35 and 28.
Okay, and then we put a 3-inch border around it.
So again, I'm going to go 3 inches to the right and 3 inches to the left, adding a total of 6 inches.
So that's now 41, and then 3 to the top and 3 to the bottom would make that now 34.
So area equals.
So 34, now we got it, times 41. And we get 1,394 square inches.
Okay.
Wow, we did it. Okay, we just got one more type of problem to show you. So they have some circles that are inscribed in rectangles, and they give us the radius of the circle. And from that, we got to find the area of the rectangle that contains them. So the secret is we have to find the width and the length. So if you go draw a vertical line through the center.
Okay, so this radius doesn't do us any good, but if we draw it vertically,
we get the width of the rectangle.
Absolutely.
So
yeah, let's redo it. So the width is 12.
Right.
Okay, 6 plus 6.
Because this 2 radii form the width, and then we can find the length of the rectangle. So all radii of the circle have the same length, so we're just using more useful ones. So we see as we go from the left side to the right side, we have 4 radii.
Okay, so our length will be 24 in this case.
And we just got to do 12 times 24.
So area equals. Okay, what do we get for that?
288. And this would be centimeters squared. So we know we want an area of a rectangle. We know somehow we have to find the width and length from the information they gave us. Okay, this is a similar problem. They want the area of the rectangle. This time we know the radius of each circle is 4.
So again, if I go horizontally, okay, we have 4 and 4 and 4 and 4. And if we go vertically,
we have 6. We're going to have 6.
Okay, so again, this is 4, this is 4, this is 4, 4, and 4. So for the length, I have 24.
Mm-hmm.
And for the width, I have 16.
That's 384.
Okay, and units are inches in this case. So inches squared.
Awesome. Okay, those are the examples. Time for the journal assignment. I love this quote from Einstein. It says, "We cannot solve problems with the same thinking we use that created them." Awesome. So if you got problems, you got to think differently about problems. So that's good advice. All right, well, anyway, same sort of problem. In 1A, you're going to find the area of the original poster. So it was 12 by 18 was the original. You're going to find the area. And then we added a 2.5-inch border around it. So for question 1B, you're going to find the area of the picture and the border together. And then for part C, you're going to find the area of just the border. So you got to think about that one. So if we know the whole area and the area of the picture, how can we get the area of just the border? That's what 1C is asking. And then for problem number 2, we have a problem just like we just did. Find the area of that square.
So just draw a more useful radius that will give you the dimensions of the square.
You got it. See you next time.
Good luck.